like to thank Nag Research Heights and Dr. Nagendra Garu for giving this opportunity on a very, very important topic for the nation, that is research and deep technologies for a sustainable Bharat. As a country, we grow towards a fully developed country and a goal of Vikasit Bharat by 2047. I think our work on deep tech technologies is very, very important. Of course, the context of my presentation is going to be on a mission-grade missile systems. The defense plays a very, very important role for any country. And we are seeing how some countries come under pressure because they don't plan adequately for the defense of the nation. And defense primarily depends on the technology. And the technology gives the empowerment of the defense for the nation. So in that context, India also has been working on the defense technologies. And coming on to the focus to the missile technologies, the main focus started with IGMDP when Dr. Kalam started Integrated Guided Missile Development Program. Till then, India was only importing systems, and that's the time it was decided that India should start working on missile technologies. And the work has started. But the divide was so huge that when we started with IGMDP, there's almost 23 years of gap between those advanced countries and what India has just started. But I'm very glad to say that the continuous years of research by many institutions, not only DRDO and even other scientific establishments like ISRO, then partly DIE, CSR labs, and then academic institutes. Today the gap has been narrowed down quite a bit. But defense also is going through a lot of changes. Some of you who are following some of the recent conflicts, you find that the pattern of the wars are changing. The wars have become technology-driven wars. Earlier, everyone thought the mightier the weapons, the aircraft were the ultimate, the tanks were the ultimate, the ship were the ultimate. But if you can see the recent wars, whether Russia war, otherwise Iran-Israel war, in fact today only the other war has started, you find that all these big missions are not nowhere. The small missions, weapons which are more precise are making the difference in the battlefield. This has been possible only because of technology. The better the technology, that much more precise the weapon could be, so weapon can be smaller. There is a changing paradigm of the missile technologies. Earlier, people talked about big weapons, any weapon carrying out tons of warheads, and then even in some cases people used to talk about megatons. The missiles of long range, but never the focus was on technology. The focus was on getting the range and then carry the big weapon. But today, the focus is on carrying a very, very small weapon. If you launch a weapon, that should not cause any other collateral damage. It should be pinpoint accuracy. If I launch a weapon in the room, ideally weapon should engage the person whom you are targeting, person or system what we are targeting, and nothing else in that room also should be affected. This is the type of precision we are looking at, and the whole world is working at. And not only this, the size of the weapons and precision, the concept itself is changing. Earlier, all the wars we fought earlier, where they were basically the platform-centric wars. That means the soldier was having the weapon, the pilot in the aircraft, or even ship where the navy, the sailors used to steer the things. Today's wars are fought on network-centric. That means gun is somewhere, operator is somewhere else. And sitting in Hyderabad, I can control war which is going on. Ideally, I can control which is going on in Africa, Americas, or any other continent also. Because we get the information in enablement of IT environment, and especially communications. We have seamless communication available. We have seamless sensors available. The information on the warfare is relayed through communication means to the central place, which could be continents away. Decision can be taken. Even today, the decisions are also automated. These decisions can be communicated to a weapon which can be remotely operated. So this is a changing concept of the warfare, the network-centric warfare, in which, as we see that the role of humans is coming down. More and more systems are automated, and most of the systems are being deployed remotely and then operated. And earlier weapons used to be something like probabilistic. That means accuracy was not much. You launch a weapon, you launch 10 weapons, then you say go by probability. My SSKP is 0.7 or 0.8. So to effectively kill a target, you have to launch around 10 odd weapons. Then you know that 4 to 5 weapons will go and inflict damage. Today we are going for deterministic systems, no longer probabilistic. We will launch a weapon, then that must go and engage. That type of reliability we are bringing into the systems. So this also calls for high order of reliability. When I say reliability, that means we have to take operating conditions into consideration. Normally when you buy any electronic component, we are very happy as long as they work in an air-conditioned environment or probably in a house. But when we talk about defense systems, especially for a context of Indian defense, the systems have to work in deserts where temperature go as high as 55 to 60 degrees centigrade. And they have to work in very, very high altitudes like Siachen, where temperature goes down to minus 40 degrees centigrade. Not many systems or even components are made to these specifications. How do we ensure that the weapon, which is a complex mix of so many different components and subsystems, will function when we want without fail in these conditions? That is the challenge in making the mission grade missile systems. Now, another problem what we face is the miniaturization. Like you all are aware, how, in fact, before me, the gentleman from data systems are talking. Like you see the type of scale, talking about, gigawatts of energy, and then, the type of thermal loads we are talking. But here today you talk about weapon systems. The weapon systems are getting miniaturized. And you would have seen in newspapers, like what Ukraine has done. They sent one small FPV drones, a number of them in a container truck, and then they could unleash such a damage onto the strategic air force of Russian. And how Israel could send pagers, which were very, very tiny devices. They use the pagers to neutralize some of their adversaries in Hamas. So these all are leading to miniaturization. And this way I think as a country also this is an area where we need to work. Like world has moved already into almost like 4 nanometers type of components. But I think we are still struggling. But at least I am thankful that government is working. And I think very soon we will have at least 28 nanometer type of foundries where we will have our components. Unless we have the miniaturization, we won't be able to systems which are small enough. And today the platforms need to be much, much small. And suppose aircraft has a limitation in carrying of number of payloads, number of ordnance or number of warheads that can carry. The smaller the systems, more number can be carried and then same can be used. This is another challenge we are facing. Now for having the mission grade missile systems, one of the biggest challenge the nation faces is availability of ecosystem. Like defense has been always pursued as an area which is highly capital intensive. Like someone says that making a weapon or making of any of the systems needs very, very big capital investment. And our systems are such that there is no guarantee that you get an order. Like we have so many industries working for us and subsystems. When we ask them why you don't work for a major subsystem, we say, sir, where is the guarantee that we get orders? Like we are willing to invest 1,000 crores. But do we get orders? Our procedures are much, our testing methodology is such that we don't even qualify to this process. And the government says that industry to be developed. Industry says that we should get orders. I think we are in this dilemma. Which one is the first? So for the nation to grow, to have more and more mission grade missile systems, first we should establish ecosystem. You see US government. In US, most of the production of the armament systems are done by private industry, be it Raytheon, Lockheed Martin, a number of companies. And here in India, we don't have even one such company. The advantage of such companies, such big companies is not only that, they'll make up the systems, they also carry out independent R&D also. And they contribute greatly to the country's economy. In our case, most of the systems were imported till a few years back. And that itself used to be almost, lakh crores of rupees in some years. But now the trend is changing. You'll be very glad to know that from past 3 years, we started exporting the weapons. And very soon, our target is within 3 years, we have to export at least 50,000 crores as per government's mandate. So that way the scenario is changing and very soon we will have exports also. But the challenge is the ecosystem, where sustenance of ecosystem is very, very important. For this one, everyone needs to work together, not only DRDO, then services and industry, academia, all need to work. Here another dilemma comes in, where do we start working? Should we start working on a basic research? Should we start working on applied research? Or should we lead into production? Now the basic research primarily is handled by academia. Like though DRDO works that, but our main focus is on system development and application development. Here we have academia and even some of the CSR labs which come in for a basic research. and carry on till up to certain level of applied research. Our role starts from applied research and carrying on till up to production. But this is a place where we have major problems today. Though we develop a product, but most of the time it doesn't, get into full production. I'm sure you all are aware of the valley of death. Like we design a system, we realize a prototype, we test it. But getting across for production, making it, production ready, and then seeing that, the particular product is produced in many numbers is a big challenge. Because for that one, the productionization process, industry readiness, and the sustained orders, these are the bottlenecks. So today, most of the products, what we are realizing, they are, somehow struggling around valley of death, but, with the government's push, now past 4 or 5 years, we are finding that many of them are getting produced, and as I said, they even started exporting also. Another challenge we have is innovation. Like we are working on, many technologies. Like we have, many laboratories, many academia working on technologies. But while our technological base is growing, we are still not able to break that innovation ladder. The main benefit of these technologies will come if you are able to convert these technologies into application. So that's where, all these years we are struggling that yes, we are working on the technology, we are making products. But by the time they come out after production, that is, not only development, testing and then production. By the time they come out, they almost come close to their useful life in the sense that, obsolescence will be in the way. But if you are able to bring out innovative ideas, then we have a long time of availability for the systems which can be used in actual scenarios. So this is one area where, we all need to work. And I'm happy to say that today with the evolution of startups and the ecosystem that is being brought in, now slowly we find that innovation also is coming into our systems. We are working on many challenging areas. We are working on hypersonics. I'm sure you all must be hearing these words: hypersonic, scramjet, ramjet, and quantums, artificial intelligence. These are all areas we are also working on this one. We made a good progress. But again, to say that, we have worked in a mission mode and then we have the projects which can be deployed, I think still we are some time away. One of the biggest problem is we need ecosystem. Like today we talk about hypersonics. How many places do we have research going on in hypersonics? How many facilities do we have to support this type of research? And as such, in whole world also not more than 5-6 countries are working in these areas. If you have to compete and then stand among those groups, then our research needs to be scaled up much, much higher. So that we look into the future, coming in 5-10 years, the hypersonic systems, the propulsion wise, though we already made a breakthrough. In fact, I will very happy to say that at least in one of the systems, we achieved such a milestone that we are the only one country in the world where we done such activity. Last month, we conducted a scramjet engine test for 1,000 seconds. Which is a record till date. Otherwise, all other technologies were only followers, we never been leaders. But at least this test we can say that, that way we could break that ceiling. Then, world is moving towards, quantum and then artificial intelligence. We all are aware that artificial intelligence summit was held in Delhi, where so many applications are brought. But I think, for defense, especially missile systems, artificial intelligence plays a very, very vital role. We are already working on many systems where we find that by employing artificial intelligence that we are able to home onto the target very quickly and almost at the ranges double than which otherwise, with the normal contemporary systems. That where work is going on. Now, the most important thing is, the enablement of the ecosystem, the procedures and time to delivery. Now, as a country, like, as I said that initially gap was quite high, now the gap is shrunk significantly. But for us to move forward, there are many other areas where we can claim leadership. One is the space technologies. Though we are very fortunate that, like India has already established a good lead in the space technologies, in the civilian space technologies. But when it comes to defense space technologies, we are seeing the past 5-6 years, every country is working on space. Now, we are also seeing the effect of the space dominance, the ISR capabilities, how they'll complement the battlefield with the ongoing wars. So this is one area where we need to work. And second thing is cyber domain. Recently, we all read in newspapers what happened when US picked up Venezuelan's president. They said first, through cyber attack, they neutralized all those, enabling things, and then quietly with a small contingent came and picked it up and all. These type of, the techniques are being used in the warfare. So as a country, we need to grow into this one. Now for this, we need to work more and more on real-time systems with processing times of less than even 1 millisecond. Today, we say that in some of the computation cycles of some our systems are around 2 milliseconds or 3 milliseconds. Probably we need to work on even much faster systems, and many of the systems which can have asymmetric warfare capability. Today, warfare is not going to be the major warfare. Unfortunately, today with war has started, but otherwise, most of the engagement is going to be asymmetric zone, the low intensity conflicts which will continue for a long time rather than having a war of big magnitude for a short time. This is going to be the thing. And for this one to sustain our lead in technological domain, we need to work on materials, because materials, though we made a very good progress, but still materials is a challenge. We have a lot of dependency on materials from abroad. We don't get magnetic materials, we don't get energetic materials. And in addition to this, even technical materials also. Our aero engine program had to wait for a long time for advanced materials. Today we are working on hypersonic systems where the skin temperature goes to more than 2000 degrees centigrade. What type of materials are required to sustain these type of temperatures, to give a required thermostructural strength. So these are the challenges we have in the materials. And also as a semiconductor also. Like as we move on to higher and higher, earlier we talked about probably, we thought gallium arsenide itself is one of the big thing. Today, GaN is also going to going to be replaced. So these type of changes are happening, and we work on many systems. The efficient way of integrating the systems will make sure that we have the mission grade systems available. But today, as a country, we can say that India is more or less self-reliant on missiles technology, and we work on missiles which are as small as 6 kgs and as heavy as 80 tons. And the ranges of our missiles, they start from minimum range from 200 meters to maximum 5,000 kilometers. And we have systems that can be launched from underwater, all platforms literally. Underwater, that means submarines, then ships. Then we have a land attack thing, that means tanks or normal vehicles or launchers. Then we have from aircraft, helicopters, and then we gone to the space. That way, I think as a nation, technologically we are getting capabilities to have weapons which can be used and then launched from any of the platforms. We are able to meet and then the objectives of the nation, and we are able to make all types of weapons that are being made by any other country. But only challenge is still, I think, because of technological probably lag of a few years, our systems are slightly bigger and then heavier. Capability we are able to meet, but only thing is not of the same size and then same volume. This is what is need of the day. And earlier our developmental cycles were almost like 10 to 12 years time. And of course, now we are trying to shrink it to 5 to 6 years time, so that right from getting idea and then making sure that they enter production, there is not more than 5 to 6 years time. Because defense research is one area where a lot of work goes on for many years. We don't come to know because of secrecies. We come to know about product or technology only when the particular product is displayed or tested. Till then, because of secrecy, the work will be carried out clandestinely, so we don't come to know. But here, we are also, as I said, that coping up with that whatever gap, and very soon we will be at war with all leading nations. And for this, the whatever encouragement given by government and the insistence, today very fortunate I can say that government says that let's be minimal import of weapons. Earlier, most of the weapons were imported. But government says that we must have indigenous weapons to the extent that they say that the wars of India should be fought with only indigenous weapons. And not only the statement, but a lot of push also is given for industries to take up independent R&D and then to all government establishments also. With this enablement and the technologies, that is also parallelly worked on in all the domain areas, be it semiconductor mission or quantum mission or whichever area we talk about it, I am sure country will become totally self-reliant, and which will help in becoming the developed nation, the goal of Vikasit Bharat by 2047. Once again, I thank NAG Research Rights for giving me this opportunity to speak about the mission grade missile systems and then how the scenario is going to be in the future. Thank you.